I am Anil Kumar. Welcome to this series on calculus. We are going to learn the concepts to find derivative of trigonometric functions in this particular video. We'll start with the basics, so this should be a very good video to start from. In case you want to learn from me, you can always send an email on the address given. Now, let us enjoy the journey of success with the student Akshit. Hi Akshit, how are you doing?
Hi, sir. I'm doing good. How are you?
Very good, very good. So today, what do you want to learn?
Sir, today I was hoping we can go over the derivatives of trigonometric functions.
Trigonometric functions. You already started? Where are you at school?
Sir, at school we're still studying e to the power of x and just exponential functions in general. So I was hoping we could work ahead.
That's good, that's good. So what type of marks are you getting so far?
Sir, I'm scoring 97% right now in calculus.
Great, excellent. So let's begin with the trigonometric functions and their derivatives. So it is a new subject, new topic for you, right?
Right.
So let me begin with the basics. I have a previous lesson prepared on it. So we'll actually take help of that lesson while understanding these concepts to you. Okay. So let me share with you what I have.
Yeah.
Just a second. Do you see my screen?
Yes, sir. I see your screen.
Very good. So we're talking about derivatives of trigonometric functions. You can see sine and cosine graph right there. Right. So the red and the blue graphs, you see the red graph, it is which graph?
The sine graph, sir.
And the blue one is the cosine graph, right?
Yeah.
So they are both related. Can you tell me how they could be related?
Yes, sir. I think we said that the derivative of sine x is cos x, right?
Correct. And even cofunction related.
And cofunction,
right?
yeah.
A phase shift of 90 degrees, basically, right? Or pi by 2. Now, it is important to understand that when we talk about derivatives, we are always looking into units as
radians.
Radians. So that is a must, right? So that is a must. So you should remember all the units are in radians.
Yeah.
The reason is very simple. Reason is when you want to evaluate the limit of this particular function, sine x over x as x approaches 0, it is equal to 1 only in radians. So remember this part. So when we talk about sine x over x limit as x approaches 0, it is equal to 1 only if x is in radians.
Yeah.
Now, this particular limit is the base of all the derivatives, and therefore, we'll look into this also while discussing. Correct?
Yeah.
If you try sine x by x in degrees, you will not get limit. It does not exist.
Right.
So that's one thing. And then we'll look into how do we find derivative of these functions and relate them. So we'll have some practice questions based on that.
Yeah.
So let's begin with the limit itself. So limit is the value which we are approaching, correct?
Correct.
You may or may not be there, but you could approach. For example, when we talk about sine x over x, we know that x is not equal to 0, right? Because you cannot divide by it. But the limit exists because we are talking about approaching 0. We are not there, right? We are approaching there. And therefore, the limit approaches, and we'll just show you that this is 1. Many ways to show this. One of the best method which is we can just put in some values and approach practically. Right? So you can see that here we're trying to work out the limit of sine x over x approaching from the left side of 0 and approaching from the right side of 0. So when you plug in the values, let us say when you want to approach from the left side, let us say this is our number line, right? And we want to approach when x is equal to 0, right? From the left side means minus. In that case, you could start with, let's say, -1 and come closer and closer. So we have values for this expression, sine x over x, for -1, -0.1, -0.01, -0.001. You see,
Yeah.
it approaches 0.99999, which is as good as 1, correct?
1. Right.
Similarly, from the right hand side, plug in 1. In this expression, sin x by x, all in radians. 0.1, 0.01, 0.001, you approach 1, right? Both sides
Right.
0.99999. So therefore, you could say that the limit exists and it is 1. Perfect.
1.
So that is our basic limit which we are talking about. Now from here, we could also figure out that the limit for cos theta minus 1 over theta is actually equal to 0. Well,
Yeah.
that is, you can see from here, well, we can derive it from this particular limit known to us. So here is the way to do it. So we are just going through these things since, some of them are given as examples in the books. But it's good to understand how do we derive at these results. Is it okay?
Yeah.
At times, this could also be a test question. Find the limit. So we, of course, are looking into derivatives, but first thing is let's begin from the first principle. Try to understand the limits.
Right.
And then we'll come to the derivatives. That's the whole idea, right?
Yeah.
Now, we know that the limit of sin x over x when x approaches 0 is 1. We need to figure out what is the limit of cos theta minus 1 over theta. Well, if I substitute 0 here, what do I get? Substituting 0 will be cos of 0 is 1, right?
Right.
So 0
Yeah.
over 0. Now, 0 over
Indeterminate.
0 is an indeterminate. But that also
Yeah.
tells you there could be something common which can cancel out, and we may actually
Right.
the limit, right? So whole may be there at x equals theta equals to 0, right? Okay,
Right.
let's look into this. So what we've done here is that we have multiplied by cos theta plus 1 and divided by cos theta plus 1, as good as rationalizing the numerator, right?
Yeah.
So we really want to get sine theta. We know limit of only sine theta, right? Sine
Right.
theta over theta. So we are trying to get the same expression, and we know cos square theta minus 1 is related to sine square theta. So that could help us. So by rationalizing, we get cos square theta minus 1 divided by theta times cos theta plus 1. What is cos square theta minus 1?
Sir, it would be minus sine squared theta.
Minus sine square theta in the numerator. And now you can write it like sine theta over theta as one part, right? And the other sign you can write over cos theta plus 1. You see that? We kind of
Right.
rearranged our expression. So sine square theta has been split into sine theta times sine theta. Under one sine theta, we have put theta. We know that limit is 1, right?
Sir?
Yes.
So where would the minus sign go in this case? Did we
Outside.
factor it outside?
Outside.
Okay. Yeah.
Because minus sign is not going to change, right? So
Right.
we kept it outside. And now sine theta over theta. You know the limit properties. Limit of each can be found separately
Yeah.
and multiplied. So we have limit of sine theta over theta times limit of sine theta over cos theta plus 1 when theta approaches 0, correct?
0. Yeah.
The first expression is 1. The second, when you plug in 0, sine 0, is 0. But cos 0 is 1. So 0 divided by 1 plus 1, which is 2, is 0.
Is 0.
Therefore,
Yeah.
the whole expression equates to 0. And therefore, we know that this limit is equal to 0. Correct?
Yes, sir.
These are two fundamental limits which you should know when we are working on derivatives of trigonometric functions. Many times,
Yeah.
the question is just based on finding the limits. You get the idea.
Yes, sir.
For example, I will say, now find the limit. Theta approaches 0 for, let's say, sine 5 theta over theta. What is the answer? Tell me.
Yes, sir. So would it be 5?
So how will you do it? You could multiply this by 5 and divide by 5, correct?
Correct.
So you could take that 5 outside and say limit theta approaches 0 for sine 5 theta over 5 theta. And this limit is 1, correct? So 1 times
Right.
5 is 5, correct answer. You get the idea? So
Yes,
that
sir.
is how you're going to figure this out. So that gives you a good exposure of limits based on this. Remember, we are talking about radians, right? You know
Yeah.
how radians are related with degrees? Very
Yes, sir.
important
The
formula,
formula.
right? One full circle is 360 degrees. And the same
Yeah.
circle is also 2 pi, correct? So one full circle
Right.
is 360 degrees, and this is also equals to 2 pi. So when you relate the two, you do get 180 degrees as equal to pi, and that helps you to convert your degrees to radians if required, right?
Yes,
Now
sir.
let's look into the graph of the function. In red, I've shown you the graph of sine function, right?
Right.
Let's look into this graph and try to draw a tangent. If I draw a tangent at the turning point, what do I get? I get a 0, right?
Right.
That means that derivative at that point, which happens to be pi by 2, will be 0, right?
0.
Similarly, derivative here will also be 0.
Yeah.
Then you see it is as good as 1, right?
Yeah.
So we could take another point here. This place is minus 1. So let's take a point here. And this place is again positive 1. We can take a point 1 here. If I connect these points, what do I get? I get the
Cosine graph.
cosine graph. And therefore,
Yeah.
they are related. So the derivative of sine is cosine. We can see it from the graph itself. Got
Yeah.
the idea? So even without doing much of calculation, we can straight away say that if the function is sine x, in that case, derivative of the function is cosine x, which is very clear from the two graphs.
Right.
Perfect. Now, it's important to find the derivative algebraically. Well, basic rules, you know, how do we find derivative? You can use one of these limits, right? First
Yeah.
principle. So you could use, this is your difference quotient formula, which is normally
Right.
used to find the derivative using first principle. You're familiar with it, right?
Yes, sir.
Correct. So we are going to use the same thing to find the derivative for sine function. So
Okay.
let's take the function f of x equals to sine x. In that case, what is the derivative of this function? Limit h approaches 0 for f of x plus h minus f of x over h, correct?
Right.
So sine x is our function. Let's write f of x plus h, which is sine of x plus h
X plus H.
minus sine.
Yeah.
You remember the compound angle formula? What is
No,
sine
sir.
of
I
a
think
plus b?
I forgot it, sir. I'll note
Okay,
it
let
down.
me write down sine a
Yeah.
cos b plus cos a sine b, correct?
Okay. Yeah.
So we are going to expand this using this compound angle formula, x plus
Yeah.
h, right? So sine x cos h plus cos x sine x. So that is your first term. The second term is minus sine x.
Minus sine.
Now after this, we'll do some rearrangement. Look here,
Yeah.
it's a game of rearrangement. So this sine x we brought on the other side. You see that? So
Yeah.
that we could factor out sine x, and that cos x term we brought separate. Is that clear to you?
Yes, sir.
We wrote it. And h is a common denominator. Dividing this, we get that expression. Now, in the first expression, you can see we could factor out sine x, correct?
Sine x. Right.
We get cos h minus 1 over h. And in the second expression, I wrote this as cos x over sine h over h. Right? We have a limit where h approaches 0, right? So h is
Right.
approaching 0. Now, look here. Since this expression we know is what? Limit of cos h minus 1 over h is what? We just figured it out. It is 0, right?
Yes, sir. 0.
So when you multiply 0 with anything, you get 0.
0. Yeah.
That term is 0 for you, correct?
Correct.
Now the second term. We know that sine h over h is 1, correct?
1. Yeah.
Limit. And what are we left with? Limit
Cos x.
when h approaches 0 for cos x. It is independent of h, right? So you are
Yeah.
left with cos x. You see that? So we have got the derivative of sine x as cosine x. Is that
Right.
clear to you?
Yes, sir.
I like you to go through this derivation once again. Get the whole picture in your mind. It is a
Yeah.
very important derivation.
Yes, sir.
Some steps are very, very critical, especially this one, right? How do
Yeah.
we split and then use the two limits which we learned in last 10 minutes to apply and get the result in the next minute? Do you see that part?
Yes, sir.
Very clear?
Yeah. Very clear.
Shall we move forward?
Yeah.
Now let's do the derivative for cosine x. How will you find the derivative of cosine x? Here's a very short trick. We started with the relation between sine and cosine, correct?
Correct.
So cos x is related as a co-function identity with sine x, right?
To sine
we
x,
now know the derivative of sine x. Why not to write cosine as sine and find the derivative? That is the whole idea. See how easy it is? We began with f of x as cosine x. But we know cos x means sine of pi by 2 minus x.
Minus x.
So you remember this? If I have this triangle, let's look into it. So I'm saying that this angle is x, correct? So in that case, what is cos x? Cos x is, let's say, a, and this is hypotenuse, this is b. Then cos x is a over h, right?
Right.
And this angle is pi by 2 minus x, correct?
Correct.
And what is sine? Pi by 2 minus x. Co-function identity, you know that. So we replaced cos x with the sine equivalent, co-function identity, sine pi by 2 minus x. Perfect.
Oh, okay. Yeah.
And now you know the derivative of sine x. You can apply the other derivative rules. For example, the chain rule, all other rules, right? Derivative of infinite function. So what is the derivative of sine pi by 2 minus x? Well, of course, cos pi by 2 minus x times derivative of minus sine x, which is minus 1.
Right.
And therefore, you get your expression, which is minus sine x, correct?
Yes. Sir, quick question.
Yes.
So in our first step of the chain rule, where we wrote cos of pi by 2 minus x, that's the derivative of sine pi by 2 minus. Okay, just sine x, right?
Sine pi by 2 minus x times derivative of inside function, right? Chain rule.
Okay, yeah.
So derivative of inside function minus x is minus, so we get minus then.
Minus, yeah, okay.
For sine derivative, we got cosine of the argument. Argument here is pi by 2 minus x.
Right.
And now cos pi by 2 minus x is sine x. So we replaced cos pi by 2 minus x with sine x. And we got our expression minus sine x. Get the idea?
Yes, sir.
Perfect. So you know the derivative of sine x. You know the derivative of cosine x. Can you find the derivative of tan x?
Yes, sir. You can do sine x over cos x, right?
Correct. Quotient rule.
Yeah.
Right?
Yeah.
So you can definitely try. And let me show you the solution. Not a big deal, right? So we apply the quotient rule. You remember the quotient rule, right? So
yes, sir, I do.
Denominator squared. So we have tan x as sine x over cosine x. So when you want to find the derivative, we square the denominator. Derivative of sine x is cos x, right? So it basically that is the formula. Derivative of sine x times cos x minus sine x times derivative of cos x.
Cos x, yeah.
You know both the derivatives. So you get cos x times cos x minus sine x times minus sine x, correct? You get cos square x plus sine square x, which is 1.
Which is 1.
And over cos square x gives you secant
square x.
So the derivative of tan x is secant square x. So that is how we get the derivative of all these 3 primary trigonometric ratios. You are encouraged to find derivatives for the secondary trigonometric ratios, right? Follow the same quotient rule for each.
Right.
What is that? And then get your result. Okay?
Yes, sir.
Very simple. So cosecant is 1 over sine.
Right? Yeah.
So you can get easily the derivative. You can also write sine of minus x and then minus sine of derivative. You understand? And you get your result. Fine. Not a big deal. So here are the formula for all the 6 trigonometric ratios, their derivative. I will like you make a copy of this. Remember, right?
Yes, sir.
Of course, you can derive, but sometimes in the test you do not have so much of time to derive each one. It's better to remember, right? Once you do 4 or 5 questions, it will be absolutely clear to you how you should write down the derivatives for any trigonometric function. Yeah. Once you know these, you can apply other rules and find your answers easily. So here are some practice questions. Would you like to do some? Try the sum out? First one,
sir.
Read and tell me the answer.
Find the derivative dy over dx of the following functions. So the first one is y equals 5 sine 3x plus 2.
Correct?
Right.
What is
so, sir, we know that the derivative of sine of x would be cos of x, right?
Yes.
So would it be 5 cos 3x plus 2?
And then derivative of 3x will be 3.
Would be
So
3.
5
Yeah.
times 3 is 15. And straight away I'm writing cos 3x. Is it okay? Derivative
Yeah.
of 2 is 0. So we get this as the derivative of the function. Clear?
Okay. Yeah.
Clear? Second one.
Yeah. So sir, this one would be 2 cos x minus sine x, right?
Product rule. Because here we have x times cos of this. So you have to apply product rule, correct?
Oh, sorry, sir. I was looking at 3. Yeah.
Yeah, you're looking at 3. Okay. Yeah. What did you say about 3? You said something very nice. What did you write? Say?
Sir, I think this was also a product, right? So
Yeah,
you would also have to use product rule over here, right?
we could do that. Otherwise, look here. What is 2 sin x cos x equals to?
So this one would be an identity, right? Yeah, sine 2x.
Sin 2x. So if you write this as sin 2x, you know the derivative straight away, right? Cos 2x
Right.
times 2 cos 2x.
Correct.
So what I'm trying to tell you here is it is not very difficult once you know the basics, correct? Apply the derivative rule. So here we use the trigonometric identity. So sometimes you may have to use the trigonometric identities to simplify an expression.
Yeah.
Applying products is not difficult, but when you do that, you will get an expression which will lead to sin 2x. Why not do it in single step?
Yeah. Right.
Can you tell me derivative for square root of tan x?
Yes, sir. So we said tan x, you can rewrite it as tan x to the power of 1 over 2, right?
Correct.
So then you can apply the power of a function rule to get 1/2
Half
times tan x to the power of negative half
negative half, correct.
times secant squared.
Perfect. You see how easy it becomes? You understand the concept now, right? So
Right.
you straight away write, oh, it should be 1 over 2 square root of tan x, correct? Times
secant
squared x, right?
Yeah.
So apply your standard rules and get all these questions easily without any problem, correct?
Correct.
You can try them. These are very popular trigonometric functions. How will you do this? Tell me.
Yes, sir. So, sir, I think they replaced the parameter x with sin x, right?
Yeah.
So there's no way we can distribute, right, sir, and call it sin square x?
Think it is theta.
Yeah, okay.
It will be cos theta, right? So it is like
Right.
cos of sin x. You see, it's
Sin x,
interesting,
yeah.
right? Times the derivative of inside function, which is cos x.
Cos x.
So that is going to be the answer. Do you see? Single line
Oh,
answer.
okay.
But you have to use your strategies, correct?
Yeah.
So these questions are asked in multiple choice, or sometimes, first 10 questions straight derivatives. Correct?
Yeah.
And then you might have something like this. And in these questions, we sometimes say, well, find the equation of a tangent line at x equals to pi by 2 or some pi by 3, for example, correct?
Right.
Find the derivative equation of tangent. So similar kind of questions we can have here also. Okay?
Yeah.
But these 8 questions will give you good practice.
Yeah.
To begin with. Okay. Now we'll go to some application questions. Okay. Read the question, please.
Yes, sir. Practice application questions, tangents and normal. Find the equation of the tangent to y equals sine 2x at the origin. Right. So, sir, we know that the point given would be 0, 0. And
yes,
our derivative would be 2 cos 2x, right?
Correct. At 0, it
and
is.
then at 0, sir, it would just be 2, right?
Correct.
So that would be the slope. So it would be 2x plus b, right?
B is 0.
Okay, yeah, b is 0, so it would just be 2x, right?
Yes. You see that?
Yeah.
Correct. So easy to find the equation. You can do the other questions, which will not be so simple as what we have, right? I mean, derivative is this. You can do the other question. Is that okay?
Yes, sir.
So, for example, question number 12. So there are many questions here. Here is an application question. Can you please read the application question?
Yes, sir. A triangle has adjacent sides of 4 and 6 units with enclosed angle of theta. prove that the triangle has the maximum area when theta equals pi over 2.
Okay. How will you do this question? So you have
Yes,
a
sir.
triangle which is adjacent sides of 4 and 6, right?
6.
Let us
Yeah,
say these are the two adjacent sides. This is 4, this is 6, and we have an angle of theta, right?
right.
Theta could be any angle.
Correct.
We're talking about a closed figure. Let's close it, right? So
Yeah.
that is our figure. Now, what is the area of this triangle? Tell me.
So it would be base times height over 2, right?
Oh, but you don't know the height. Okay, let's do
Oh,
height.
okay.
What
Yeah.
is it? Okay, let's do height. What is the height related to? Okay, now.
It would be cos theta, right, sir?
No, sine theta. It's opposite to this, right?
Oh, okay. Yeah.
Right. So base
Right.
now is 4 and height will be 6 sine theta, right?
Yeah.
And therefore the area will be half of base of 4, right? Times height, which is 6 sine theta.
Sir? Okay, yeah.
Half base into height.
Got it, yeah.
So it is 12 sine theta.
12 sine theta. Yeah.
So the derivative is what? 12 cos theta, right?
Right. 12 cos theta.
A prime is 12 cos theta. So we want to find a critical number.
Yeah.
When will it be 0? It is going to be 0 when theta is pi by 2.
Okay. Because cos of pi by 2 is 0, right, sir?
Correct. And even
Okay.
otherwise, what could the angle theta be? So a triangle has got 4 and 6, right? So to make this triangle, what could be this angle, right?
Yeah.
Find the second derivative to show that this is going to be maximum area. Let's find the second derivative. What is the second derivative for this function?
Sir, it would be minus 12 sine theta.
Correct. So for
Yeah.
that angle pi by 2, it is going to be negative 12, right?
So maximum. Yeah.
So since it is negative, the graph, you can see it is a maximum. It's concave down, correct?
Correct.
So that is how you can prove that this is the maximum area. Is it clear to you?
Yes, sir. Clear.
So let me tell you, these were not easy questions. We
Yeah.
could solve them very easily without any problems. Once you understand the concepts, you
Yeah.
just keep solving them one after the other very easily. How? So these 12 questions, which we went through in about 30 minutes time, they are very good starting points for any trigonometric calculation derivative chapter. You understood the concepts of limits. You can actually solve all the questions based on limits also using
Yeah.
the two formula which you learn, which is limit x approaches 0 for sine x over x is equal to 1, and
1.
the other, the cosine x limit when cos x minus 1 over x, limit x approaches 0 is 0.
0.
Using these two limits, you can actually solve most of the limit questions.
Yeah.
And then we looked into so many other examples. We went through the derivatives. Of course, you understood these strategies. And then
Yeah.
also, you can easily now find derivative of any trigonometric function for your records, but you should always remember the formula, and that is the set of formula which you should know, right? I can write any
Right.
function and ask you what is the derivative. You may have to use product rule, quotient rule, chain rule, whatever, but then you
Yeah.
can ultimately get answers very easily. And then we looked into practice test questions, 8 of them right there on the screen, right? You can
Yeah.
find derivatives using those rules. These are actually common test questions from previous test papers, I'm telling you.
Yeah.
Just do these. They're simple. And then an application question, it looks difficult, but then you see how easily we could do it in 2 minutes, right?
Yeah.
So with that, our lesson is over. The only thing now is you need to practice with some good examples. So let's explore my YouTube channel and see some examples where we can see how derivatives of trigonometric functions can help. Is it okay?
Yes, sir.
Okay. So let me stop sharing this. Anyway, so before we go to the YouTube channel, Akshay, can you please summarize your learnings of understanding derivatives of trigonometric functions?
Yes, sir. So when we touched upon the derivatives of sine x and cos x, right? Initially, I thought it would be much more complicated than it really is, right? but seeing how we can integrate like co-function identities and like all the laws we learned from like grade 10 to now, I think it becomes much more easier and you can do it really fast. I think it's just a matter of me like memorizing the identities and a bit more practice now.
Right. Perfect. Now let's explore the YouTube channel for other videos. So
Yeah.
let me just share the screen and we'll search. Okay, no problem. This is not required. And now let's see. So when you go to my channel, just type in Anil Kumar
Yeah.
and we want derivative, trig functions, trigonometry. You can also say applications actually. So we are just in general put this. And then
Yeah.
there are many videos here which you could see, right? So
Right.
these are all derivative examples from previous test papers where chain rule may be applied, product or quotient rules can be applied, as you can see, right? Now,
Yeah.
then there is word problems are actually very interesting questions. We have word
Yeah.
problems based on rate of change and optimization. The earlier chapters which you have done, you get the idea.
Correct.
So
Yeah.
you have to look into both type of questions. So let's look into them one by one. Here is
Okay.
very good question, which is normally seen in test papers. Can you please read the question?
Yes, sir. A 6 feet display sign is 3 feet off the ground. Find the distance from the sign of a point on the ground where the subtended angle of the sign is a maximum.
What is the meaning of subtended angle?
Right.
Tricky. So if
Yeah.
some signboard is there and you're standing here, then the angle which your eye makes, do you understand this angle which is subtended? That is what it
Okay.
means. So this
Yeah.
angle is what we are trying to figure out. Is that okay?
Right.
So now read again. A 6 feet display sign is 3 feet off the ground. It is above the
Yeah.
ground, right? When you're driving a car, for example, you see all the
Right.
signboards on the sign, right? They're above the ground, right?
Right.
So a 6 feet display means the width. We are talking about those dimensions. 6 feet display sign is 3 feet off the ground. Find the distance from the sign of a point on the ground where the subtended angle of the sign is maximum. So we have to subtend that angle as maximum. This is what it is, right? So
Yes,
once you
sir.
understand, so we have taken that angle to be vertical. This is how 6 feet. So 3 feet off the ground and then 6 feet above, right? That is the signboard. So we have to, in this particular case, write down the trigonometric relation first. Then we have to find the derivative. So the trick part is, how do we write the trigonometric function? You see, so
Yes,
as you
sir.
can see from the diagram, clearly, the red triangle is what we are interested in. The green triangle shows you that the display board is 3 feet above the ground. And point P is from where you're observing. Correct?
Yes, sir.
Now, we have used this tangent ratio because that angle theta is actually difference of beta and alpha which you have shown in the diagram. I would like you to go through this video to understand how do we get this equation. Is that okay?
Yes, sir.
Okay, so once you get this equation, because we know the distance 3 feet, right? And x be the distance away from the horizontally away, right? So you can relate all these tan values with respect to x, because tan is opposite over adjacent.
Yeah.
They are given the heights. So all tan alpha, beta, theta can be written as that height over x distance. And that is how you are actually going to get the formula, because we are talking about an angle which is beta minus alpha. You know the expansion, tan beta minus tan alpha over 1 plus tan alpha beta, right? As written here.
Yes, sir.
Once you get this formula, you first you have to visualize and then get the formula and then find the derivative and then maximize the result by equating the derivative to zero. Find the critical number, right? The whole amount of exercise. So it's not an easy question, pretty difficult to begin
Yes,
with.
sir.
Okay, but it's a very important question from test point of view. Likewise, we'll have about 50 questions just based on applications of these things. But if you just scroll through, you will see many. You know, just as we did nested square roots, you remember how chain rule
Yes,
was
sir.
applied?
Yeah.
You could have nested sign as shown in this particular example, correct?
All right.
So what I would like you to do is really explore my playlist on derivative. And there are many examination style questions. For example, this particular question which you are seeing now is from GCSE at Excel, right? So where we have a function y equals to 3 sine theta over 2 sine theta plus 2 cos theta, right? And theta is between minus
Right.
pi by 4 to 3 pi by 4. And then we have to work out some derivatives for given condition. Very good question to work on. Okay, I'm just looking through. There could be some very complicated questions involving logarithmic and sine functions also, which we will take in the next class, not today. Okay.
Okay, sir. Yeah.
Uh, Let me just take some questions based on ladder and other examples, which are trigonometric derivative examples extended. Let me write application. So we have a playlist which says trigonometric functions, derivatives, and applications, AP Maths. AP Maths is a curriculum followed in US. Okay.
Yes, sir.
Well, we can look into this list. So rate of change questions are also there, based on which we could find some questions. So please read this question.
Yes, sir. A balloon leaves the ground 500 feet away from an observer and rises vertically at the rate of 140 feet per minute. At what rate is the angle of inclination of the observer's line of sight increasing at the instant when the balloon is exactly 500 feet above the ground?
A simple question like you had in rate of change earlier, right? So those kind of questions. And then we have ladder questions. Now, ladder questions are very typical. Can you please read this question? Rate of change, ladder.
Yes, sir. A ladder 13 meters long is leaning against a wall. If the base of the ladder is being pulled away from the wall at a rate of 0.5 meters per second, how fast is the top of the ladder dropping when its base is 5 meters from the wall?
Right. Similarly, we could have more questions based on this situation. So I treat them as ladder questions. They're almost similar, right? And
Right.
we could have. So there are many questions. 31 type questions are given in this particular playlist, and you can find many more playlists also in this particular case. Now here is another very interesting question. Can you please read the question?
Yes, sir. Find the maximum perimeter of a right triangle with hypotenuse of k centimeters.
Extremely important question, because to relate your hypotenuse with the perimeter, it is actually a challenge in itself.
Right. Yeah.
See how easily using trigonometry we have done it, because
Yeah.
sine theta is y over k, cos theta is
Right.
x over k, and we know that we can relate them very easily. Perimeter is the sum of all these things, right? Which is
Right.
given to us, and you just differentiate with respect to theta, and you'll get an expression which can be simplified, and you can find the answer as shown here in this particular example. Do you see that?
Yes, sir.
So like this, there are many uh, questions which could be done, and here is point of inflection. That is kind of sketching the graph. You see,
Yeah.
so curve sketching you have learned, where you have learned point of inflection, concavity, and all those things. So those
Right.
will also be there in trigonometry part. Now, the next question which I am going to share with you is an example with the trough. You have done this example without trigonometry earlier, right?
Yes, sir. I remember this. Yeah.
But you could do with trigonometry much more easy. So if this is a question, see how trigonometry helps you to find the solution. So on one page, we have the full solution right before you, correct?
Yes, sir.
So if you explore this particular playlist, you will actually come across many, many test questions, and they will help you gain confidence in doing
Yeah.
this particular unit on trigonometric derivatives. Is that clear to you?
Yes, sir.
So Akshay, I'll leave you here so that you could actually explore this list and others, because if you just type in general, I mean, this is excellent. Let me just share this. I'll share this playlist with you. You can always search, of course. But if you just search more videos, there will be few lessons which I've done with Amy. like this, right? So
Yeah.
trigonometric identities and applications. So in such lessons also, this is not on derivatives, but you'll get higher order, higher complex questions which we have solved together uh, with trigonometry, which could be
Yeah.
of use. You need not do cos inverse at present. I think that may be the next chapter for you. But for
Yeah.
now, inverse trigonometric ratios is not what you should be looking at, right? And this is actually your unit, derivatives of cos function. So that's another
Yes, sir.
very good playlist with just 14. I think that is better for you, apart from what we just shared with you. Uh, so you can actually explore and look into these. Is that okay?
Yes, sir.
So we'll end our lesson here. I will just share this link with you. You can watch these videos. And in case there is any difficulty, let me know and we can work on those questions. Perfect.
Yes, sir. Sounds good.
Correct. So can you summarize today's lesson?
Yes, sir. So, like we said, we touched upon like a bunch of videos and the lesson in general about trig functions, right? So, I think like if I just memorize the identities and everything along with it, sir, and practice a little more with the videos, I think I should be good to go.
Sure. Yeah. Yeah.
Yeah.
Okay, then spend time on practicing. That is what I.
Yes, sir.
And wherever you get stuck, feel free to just WhatsApp me or send an email. I'll
Yeah,
be
for sure.
here to help you out. Okay then.
Okay, sir.
Okay, great. Thanks. Have a good day.
Thank you, sir.